Assalamu alaikum everyone. My name is Sir Shahriyar Hussain and I will be solving the 9709 February March 2026 paper, paper 1, right, of AS level. Right. So let's begin quickly, right? Okay. So the first question here is the equation of a curve is y equals to x cubed minus 3x squared plus 9. Find the coordinates of the stationary points of the curve and determine their nature. Now, to find out the stationary points, basically what we need to do here is we know that at the stationary points, dy by dx equals to 0, right? Therefore, so let's differentiate this equation, right, and equate it to 0 to find out the stationary points or the x coordinates of the stationary points. So the dy by dx equals to 3x squared minus 6x, right? Upon equating this to 0, we are going to factorize it. After factorizing it, we will be getting 3x x minus 2, right, equals to 0. So 3x equals to 0 or x minus 2 equals to 0. The value of x for one coordinate is 0 and the value of x for the second coordinate is 2. Now, plugging it into the equation, right, y equals to 0 cubed minus 3 times 0 square plus 9. We get the y value as 9. So one coordinate we are getting as 0, 9, right? And once we plug in the other coordinate, 2 cube minus 3 into 2 square plus 9. So this turns out to be an 8 minus 3 into 4, 12, right, plus 9. So this turns out to being 8 minus 12 is negative 12 plus 9 is 4. So y equals to 5, right? And the other coordinate is coming out to being 2, 9, right? Sorry, my bad, 2, 5. And that is your answer for the coordinates of the stationary points. Now, we need to determine their nature. For determining the nature, we need to find out d square y by dx square. Basically, double differentiate the equation that we had before. So we just need to differentiate the already differentiated equation, and that is coming out to being as 6x minus 6. Right now, what we need to do here is we need to plug in the values of x's that we got. So once we plug in the value of x equals to 0, d square y by dx squared equals to 6 into 0 minus 6, which equals to minus 6. As this is less than 0, therefore this will be a maximum point. Okay, similarly, we have over here x equals to 2. And upon solving this, d square y by dx square, this equals to 6 into 2 minus 6. So this turns out to be a positive 6, right? Since this is greater than 0, therefore this is a minimum point. Okay, so yeah. And let me just tell you what were the coordinates. This nature was for 0, 9, and this was for 2, 5. Now, let's attempt question number 2, right? So it says that the diagram shows the triangle ABC with AB being 12 centimeters. All right. AC equals to 9 centimeters and angle CAB equals to 0.8 radians. An arc with center A and radius 9 centimeters is drawn inside the triangle as shown. The shaded region is bounded by this arc of the line segment BC and part of the line segment AB. Find the perimeter of the shaded region. So the perimeter of the shaded region includes the curved surface, right? Which we can just find out using S equals to R theta. S is the part of the curved surface. R we know, which is 9, and this is 0.8. So 9 into 8 is 72, and the decimal in between will give us 7.2 centimeters. All right. So then we come on to this part. Let's call it XB. Now, since we know that the radius is 9 centimeters, right? So that means that XV equals to 12 minus 9, which equals to 3 centimeters. Then we come on to the final part, which is CV or BC, you can call it. We will be solving this using the cosine law. Cosine law dictates that the side that we want is equal to the Rest of the two sides, 9 square plus 12 square minus 2 times the sides, right? Multiplied by the cos of the angle opposite to the side that we are trying to find out. Okay. So therefore, BC, where's my calculator? Right over here. So BC comes out to being 9 square plus 12 square minus 2 into 9 into 12 into so 9 square plus 12 square minus 2 into 9 into 12 into cos of 0.8, right? Under root of this, BC is coming out to being 8.63. So the perimeter is just going to be 8.63 plus 3 plus 7.2 centimeters. So that comes out to being plus 3 plus 7.2. That comes out to being 18.8 centimeters, correct to three significant figures. Okay. Now, part B says to find the area of the shaded region. The area of the shaded region is just the area, is just the area of the triangle minus the area of the sector. Okay. So area of the triangle comes out from the formula of area of triangle equals to half AB sine C. So this comes out to being 0.5 into 9 into 12 into sine of 0.8. Plugging this into the calculator, 0.5 into 9 into 12 into sine of 0.8, we get 38.74, correct to four significant figures. Yeah, one more thing that I forgot to mention here is that since they've asked for three significant figures specifically, so we are going to do our working correct to four significant figures. Now, the shaded region, now we just need to find out the area of the sector, right? And that is just going to be half times r square theta. So this is 0.5 times 9 square times theta, or rather 0.8. Plugging this into the calculator, we get 0.5 times 9 square times 0.8. We get 32.4 dot, right? There is no, extra thing. There's no four significant figures to this. It ends over here. So the shaded region comes out to being 38.74 minus 32.4. So 38.74 minus 32.4, we are getting the answer as exactly 6.34 centimeters square. And that is your final answer. Question number 3. The graph of y equals to ax squared plus bx plus c has its vertex at 3 comma minus 5 and intersects the y-axis at 0 comma 31. Okay, so we need to find out the values of the constants a, b, and c. Okay, so one thing is clear over here, that y equals to ax square plus bx, and c over here is just going to be the y-intercept, so that is 31. All right, now vertex. Vertex is basically another name for the turning point. So we know that the dy by dx of something is 0 at that specific x coordinate, right? So if we were to integrate this, dy by dx would be 2 times ax plus b. And once we plug in the value of x, which is just 3, so we get the value of dy by dx being, or rather, since we know that this is equal to 0, so 0 equals to 6a plus b. Okay, so that's the equation that we get right now. And what another equation that we can get is once we input these exact coordinates in the original equation. So let's do that. That turns out to being negative 5 equals to a times 3 square plus b times 3 plus 31 that we've originally got. So negative 5 equals to 9a plus, or rather, let's just write it as, oops, negative 5 equals to 9a plus 3b plus 31. So we are getting over here 9a plus 3b equals to negative, what are we getting? Negative 36, right? Okay, so from the first equation, B turns out to being negative 6a. Let's plug that in. So we are getting 9a plus 3 times negative 6a equals to negative 36. 9a, 6 3s are 18. So negative 18a equals to negative 36. Negative 9a equals to negative 36. A equals to 4, right? Once a equals to 4, then b equals to negative 6 into 4, b equals to negative 24. So these are your answers of A, B, and C being 31. Okay, that's what they asked for. Okay, so part B is the graph is translated by the vector negative 2 comma 7. Okay, uh, my bad. Find the equation of the translated graph. Okay, so basically, if I were to just look at this from the perspective of an equation, what's happening here is if we had f of x, so the translated version would then be f of x plus 2, right? Because in translation, the sign changes, opposite signs, and plus 7, because in plus 7, that sign does not change. All right, so let's do that. With the original equation we had was y equals to, since we know the value, so that turns out to being 4x squared. We know the value of b as well, which is negative 24x plus 31. So what we're going to do here is we're just going to, wherever we have the value of x, we are going to do x plus 2 the whole thing square, and wherever we, well, the rest of the thing is just 31 plus 7. So solving this, we get 4 times x square plus 4x plus 4 minus 24x plus, okay, so this is also negative 48, negative 48 plus 38. Okay, so y equals to 4x square plus 16x plus 16 minus 24x. So we are left with a negative 10 over here. Okay, solving this further, we have 4x squared, 16x, positive 16x, and negative 24. That is going to give you a negative 8x, right? And positive 16 and negative 10 is obviously just going to give you positive 6, right? So this, oh, why is there a square on my y? So the final equation then turns out to being y equals to 4x squared minus 8x plus 6. Okay. Now, moving on to question number 4, the function f is defined by f of x equals to 2x plus 1 for they've given us the domain, and as you can see, there is no equals to sign. Okay, so it is not equal to 3. They want us to find an expression for f inverse of x. So very simple. First things first, write y in place of f of x 2x plus 1 upon x minus 3. Now what we're going to do here is we are going to swap the variables. So x and this becomes y because we have to make y the subject, right? So making y the subject, what I'm going to do here is I'm going to take this and multiply it on the other side. So this then becomes x times y minus 3 equals to 2y plus 1. Solving this further, we get xy minus 3x equals to 2y plus 1. Just swap the positions, right? Throw it here and throw that over there. So we are getting xy negative 2y equals to 3x plus 1. So taking y common, we are left with x minus 2 equals to 3x plus 1. Y equals to 3x plus 1 divided by x minus 2. And the final step over here is to write f inverse of x in place of y. So this turns out to being 3x plus 1 upon x minus 2. Okay, solving this further, part B is that given that f of x equals to px plus q upon r plus s of x, find the possible values of the integers p, q, r, and s. Okay, so let me just give you the equation. F of x equals to 2x plus 1 upon x minus 3. Okay, so we have to plug it wherever there is a value of x. Wherever there is a value of x, we have to plug in the entire function of f of x over there. Okay, so this looks something like this. So this turns out to being 2 times 2x plus 1 upon x minus 3 plus 1. right? And then we have 2x plus 1 upon x minus 3 minus 3. So what we are going to do here is we are going to take LCM, right, on both sides. So this will turn out to being, what do we have over here? We have, okay, basically since the LCM is the same, so we can cancel out the denominators on both sides. So this then becomes 2 times, or rather, let me just open this up, 4x plus 2 plus x minus 3. And in the denominator, we are left with 2x plus 1 minus 3x. And the negative over here will become plus, so plus 9. Okay, solving this further, we have over here 5x minus 1 upon, what do we have over here? We have a negative x, and 9 plus 1 is a 10. So originally people write it like this, but a better representation of this would be 5x minus 1 upon 10 minus x. And that is your final answer. Okay, so since they've asked us to identify P, Q, R, and S, so the value of P will be 5, the value of Q will be negative 1, the value of R will be 10, and the value of S will be negative 1. Moving further to question number 5, we need to prove the identity, this identity, right? So basically, we just have to prove that somehow the left-hand side equals to the right-hand side. And this is very, very simple. Let's just take the LCM and see what ends up happening here. Okay, so we have over here 1 plus sine theta plus 1 minus sine theta. Basically, we just took the LCM upon, this is being multiplied with 1 minus sine theta into 1 plus sine theta. Now, the denominator is just a minus b, a plus b, right? That will be equal to a square minus b square. So, and in the numerator, positive sign and this cancel out. So I guess we pretty much proved it, right? We've got 2 and we are left with over here, and well, not pretty much. Let's just focus on it first. So this becomes out to 1 square minus sine square theta. Okay, now I think if you'll open the MF19, I hope we'll find out the equation. I don't know why I remember there being an equation for that, but okay. So if you look closely, we have over here 1 minus 2 sine square theta, right? Equals to cos 2 theta. Okay. Are you sure this is the equation? One. Okay, let me first simplify it. So this turns out to being 2 upon 1 minus sine square theta. Oh, not this one. Sorry, my bad. We are going to use this equation. The equation that is over here. If we make it the subject, so this is turned out to being cos square theta equals to 1 minus sine square theta, which is exactly what we have. So therefore, the final answer becomes 2 upon cos square theta. Hence, this is proved. Okay. All right. Now, moving on to question number 5. Oh, is there a part B? Nice. So, question 5, part B. Okay. Hence, solve the equation. Okay. We'll do nothing here. We'll just take it, take an LCM over here. Taking LCM, we get 3 plus 3 sine theta plus 3 minus 3 sine theta upon 1 square minus sine square theta. I just skipped a step there, right? Because we already know. Solving this further, we have this and this canceling out. So this will then just become 6 upon cos square theta equals to 12. Solving this further, we get 0.5 equals to cos square theta, right? So cos theta turns out to being under root of 0.5. And we need to remember, whenever there is an under root, there is plus and minus signs. Okay. So the alpha is coming out to being of, remember to, okay, one more thing, that your calculator should be back in degree mode. And if we look above for this question, I forgot to tell you that your calculator needs to be in radian mode. Okay. All right, continuing this further, the basic angle that we're getting over here for cos inverse of under root of sorry, under root of 0.5, we are getting 45. Okay, so 45 is the basic angle. And now we'll use the butterfly or the cast rule, whatever you one way to call it, right? CA, right? In these two quadrants, which is the first and the fourth quadrant, your cos is positive, right? So we are going to cater for this over here. So this turns out to being 45. So one answer of theta is 45. The other is 360 minus 45, right? So that turns out to being 315 degrees. Now, for cos negative values, we have the quadrant SCAST, right? So in these quadrants, sine and tan are positive respectively, but cos is negative. So this turns out to being 45 and 45. So one is 180 minus 45, right? Which is just 135 degrees. And the last one is 180 plus 45. So 180 plus 45 will give us 225. So this is your final answer for question number 5. Okay, moving on to question number 7. Sorry, question number 6. My bad. Question number 6. The equation of a circle. Okay, so before we move on, the generic equation of a circle is x minus a the whole thing square plus y minus b the whole thing square equals to r square. According to this, where a and b are the values of your center. All right. So as you can see that we have no values of a and b. So they've asked us to state the center and radius. Pretty simple. The center, since they've not stated any value, so the center is 0, 0. And the radius is just going to be the under root of 45 over 4, which when inputted into the calculator, it gives us 3 under root 5 over 2. Okay. Now, part B. Part B says the line x plus y equals to 3 upon 2 intersects the circle at the points A and B. So, guys, what happens here is that, we have the equation of the circle being x square plus y square equals to 45 upon 4. What we can do here is that we can take y the subject from the straight line equation. So that will then turn out to being 3 upon 2 minus x, and we can input this equation into the original equation of the circle. So this then turns out to being x square plus 3 upon 2 minus x the whole thing square equals to 45 upon 4. Okay. Now solving this further or opening it further, we get x square plus 3 upon 2 square, which is just 9 upon 4 minus 3 upon 2 into 2, so into x. So this becomes just 3x plus x square equals to 45 upon 4, right? So we are getting over here 2x square minus 3x plus 9 upon 4 minus 45 upon 4 equals to 0. Solving this further, what do we get? Okay, let's keep it here for now. All right, continuing on from where we left off. So this was the equation that we were getting for question number 6, part B, right? So let's input 9 upon 4 minus 45 upon 4. Let's see what value we are getting. The value of negative 9. So 2x square minus 3x minus 9 equals to 0, right? Once we do the breaking of the middle term, so this turns out to be 9 into 2. We get over here 6 into 3 is 18. So 2x square minus 6x plus 3x minus 9 equals to 0. So taking over here 2x common, we are left with x minus 3. Taking plus 3 common, we are left with x minus 3 equals to 0. So 2x plus 3 and x minus 3 equals to 0. One value of x we're getting negative 3 by 2, and one value of x we're getting 3. Okay, so what have they asked for? They want us to find out the exact distance of AB, right? So since we got x equals to negative 3 by 2 and x equals to 3, now we need to find out the exact distance, and that is Wait, we also need the y values, right? So, okay. So the y value, we have no issue there. Let's just input that into the equation number 1 or equation number 2 or equation number 3, whatever you want to call it. So this will just be y equals to 3 upon 2 minus 3 upon 2. And the y value we're getting is 0. So one coordinate is negative 3 by 2, 0. Inputting this into the other one, so negative 3 by 2 minus 3, the value of y that you're getting here is the opposite of that, which is negative 3 by 2. So the equation turns out to being 3 comma negative 3 by 2. Okay, so yeah, the equation for the distance is AB equals to under root of, okay, let me just write down the distance formula here. Under root of y2 minus y1 the whole thing square plus x2 minus x1 the whole thing square. That's it. So let's just plug that in. So negative 3 by 2 negative 0 the whole thing square plus 3 minus or plus 3 upon 2 the whole thing square. The value that we are getting over here is 9 under root 2 over 2. Okay, if you plug that in into the calculator. Okay. Right. Question number 7. Moving on to question number 7. The equation of a curve C is such that dy by dx equals to x minus 3 the whole thing square upon under root x. Right. The curve passes through the point 4 comma 7. Find y in terms of x. Okay. The only way to convert from a differential equation to y is by integrating it. Right. So integrating it, dot dx will move over here. So let's just write this here. Right. Dy equals to integration of x. Okay, so whenever you have these types of questions, what students usually do here is they plus 1 and then they add the power in the denominator and further. That's wrong. Whenever you have a square power, you can open the bracket, simplify it, make it easier to you for yourself to do the integration. So it becomes x squared minus 3 into 2 is 6, 6x plus 9, right? And the key over here is to distribute the denominator to each individual value, right? Dx. So what's going to end up happening here is that this and this will cancel out, right? So before we finalize the equation, y equals to the integration of x squared. As we all know that x is just x under root is just x to the power of half. So 6x upon 6 to the power of half plus 9 upon x to the power of, 6x to the power of half. Solving this further, the powers that we get are 2 minus half, right? Because the indices rule is that if two indices are being divided, their powers get minused or subtracted with each other. If you want to use official terms, so x to the power of negative half dot dx. Now, in integration, what happens in integration here is, okay, before that, let's just solve the powers. So this will be 3 by 2, right? 1.5. This will be one half, and obviously that is it. So we are getting x to the power of 3 upon 2 plus 1, which is 5 upon 2, right? And then we are dividing it by 5 upon 2 as well. Then we have over here negative 6, again, plus 1. So this becomes 3 by 2, x to the power of 3 by 2 upon 3 upon 2. And over here, the power is plus 1. So that will be positive half. So plus 9 x to the power of half, and then multiply by half. And then we have plus c over here. Basically, to find out c, they've given us these 2 points, 4 comma 7. Let's just simplify the equation first. So the equation turns out to being 2x to the power of 5 upon 2 upon 5 minus 2. Or rather, we can just cancel things out over here, right? So this turns out to being 3 1s are 3. This is 2. So this turns out to being a negative 4. Negative 4 x to the power of 3 by 2 plus 18, right? This 2 when multiplied will become 18. 18x to the power of half plus c. Once we input the values of 4 comma 7, let's do that. So what do we get? 7 equals to 2 times 4, 5 upon 2, 5 minus 4, 4, 3 by 2 plus 18 into 4 to the power of half plus c. Okay, so what do we have over here? While inputting everything, basically C will then just become 7 minus 2 times, and inputting this into the calculator, we get 32 over 5, right? Positive, since this is a positive. This will be 4 times 8, if I remember correctly, and this will be minus, just changing each sign, 18 into 2, so 36, right? So the value of C, if I plug this into the calculator, is just coming out to being as negative 49 upon 5. So the entire equation turns out to being, and I don't want to write down the entire equation. So let me see if I can copy this down. Nope, cannot copy this down. So just need to write everything down. Plus 18x to the power of half, negative 49, negative. That is your answer. All right. Okay, so part B says, okay, 2 marks, not that difficult. The equation of a different curve D is also such that dy by dx, right? This curve instead passes through the point 4, comma k. Describe in terms of k the transformation that maps curve C onto curve D, right? So for that, what you need to, all right. So the equation of a different curve D is also such that dy by dx, okay, same curve. This curve instead passes to the point 4, comma k. Described in terms of k the transformation that maps onto curve C. Okay, that's no issue at all. So in curve, what was it called? Yeah, curve C. In curve C, the point was 4, comma 7, right? In curve D, what happens here is that this is 4, comma k. So the translation vector, it is just going to be a translation, because there is absolutely no change in the x value. There is only a change in the y values, right? So this is translation. And an important thing to know here is that the vector is just going to be 0, right? There's no change in the axis, in the x values, and in the y values, it is going to be k minus 7. And why is it k minus 7? I'm going to explain it to you. Let's suppose that k was 9, right? So it would be 9 minus 7. That means it moved 2 units up. Let's suppose this time your k was 5, right? So, or rather, yeah, 5. So 5 minus 7 would just be negative 2. As we know, the difference is this 2. So therefore, your value would be negative 2, which is corresponding to the translation. Okay. Now, moving forward to question number 8. Question number 8 says that find the complete expansion of 3 minus 2x to the power of 4. Okay. So wait, let me just check one thing. 1, 4, 4, C2. Okay, so what we are going to do here is that we are going to use the formula for binomial, and that is just going to be NCR, right? A to the power of, or rather the first term to the power of n, and b to the power of n minus r. Okay, that's basically the formula for binomial. I hope it's in the MF19. Yes, 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 yes. If I remember correctly. Further pure mathematics, trigonometry, hyperbolic function, and where is it? Do not tell me. Yes, this is here. All right. So this turns out to being NCR, like I said, p to the power of r and b to the power n minus r, right? But this is the formula for statistics. In P1 binomial, they have not given the formula again for P1 binomial. Vectors, we have integration, we have differentiation, trigonometry. Yes, sorry, my bad. Right, so this is just, okay. Yeah, again, this is a to the power of n plus NCR, right? A to the power of n minus r and b to the power of r, or rather b to the power of r. Yes, 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 my bad. So a to the power of n minus r and b to the power of r. All right. Now, solving this, we have over here a 4c0. The first term is always 4. 3 to the power of 4 minus 0, and b to the power of, or rather negative 2x to the power of 0. Right. And since they said that they want the complete expansion, so what happens here is that r starts from 0 and it goes all the way to 5. Sorry, 4. Right. Because that's how it happens. So 4c1 into 3 to the power of 3 and negative 2x to the power of 1 plus 4c2 3 to the power of square negative 2x to the power of square, then 4c3 3 to the power of cubed, negative 2x to the power of cubed. Oh, sorry, not cubed, my bad. It's not going to be cubed, it is going to be power 1, right? And then 1 2 3 4, the last term, which is 4c4 3 to the power of 0 negative 2x to the power of 4. Simplifying this, 4c0 is just 1, right? Times 3 to the power of 4 into 1 plus 4c1 is 4, 3 to the power of 3 and negative 2x plus 6 to the power of 3 square into negative 2x square. Sorry, I'm going to simplify it other. Give me a minute. Yes. Continuing forward, negative 2x to the power of square. Okay, 1, 2, 3, rest. 4 cube, 4c3. What is 4c3? If I remember, 4c3 is 4, right? So 4c3 will be 4. Basically, it's like this. It starts from 1, then goes on to 4, then 6, then 4, and then what we call 1 again. Okay, so 4c3 is 4. This turns out to be 3. This is okay. Yeah, one more thing that I forgot to do here is that for positive powers, it's going to be a positive, and for, I mean, even powers, it's going to be positive. For odd powers, it is going to be a negative. Okay, and then we have 1 over here, then 3 to the power, anything to the power of 0 is 1, and positive 2x to the power of 4. Now let's simplify this. So this turns out to being, what is 3 to the power of 4? 3 to the power of 4 is 81 plus 4 into 3 cubed into negative 2. This turns out to be negative 216. So let's move that. Negative 216x. Okay. So we are done with this. Rather, we are done with this. We are done with this. Let's do this. So 6 into 3 square is 9 into 4. So that gives us 216 again. So positive 216x squared. Let's do this. So this is 4 into 3 into a negative 8. Negative 8. So negative 96 x cubed. And this is just obviously going to be positive 16x to the power of 4. Right, and that is your answer. So let's write that down, or rather just circle this. Okay. Part B. Use your answer to 8 part A to find 3 minus 2 under root 2 to the power of 4. Okay. So 3 minus 2x, in place of x we have under root 2. Give your answer in the form p plus q under root 2, where p and q are integers to be determined. All right. So let's write down the original answer that we got. We got 81, right? Plus, or rather, if I remember correctly, negative 216x plus 216x square minus 96x cubed and positive 16x to the power of 4. So we have to do nothing. Just in place of x, we have to under root 2, because the original equation was 3 minus 2x to the power of 4. If you look closely, in place of x, just under root 2 is there. So this turns out to being 81 minus 216 under root 2 plus 216 into 2 minus 96 into, okay, so I guess this would be, what would it be? Under root 2 and answer cube will give us 2 root 2, right? And then we have over here plus 16. Okay. Under root 2 to the power of 4 will give us just 4. Right. So solving this further or using, I'll just plug this into the calculator. Uh, this turns out to being 577 minus 408 under root 2. Okay. All right. Now moving on to question number 9. They want us to solve this equation. Okay. If you look closely, that the ratio of their powers is just 2:1. This is called disguised quadratics. Okay. So what we are going to do here is we are going to assume that let t equal to x to the power of 1/3. Right. So your equation will then become t square plus 8 into 1/3 into t equals to 24. So solving this, this becomes t square plus, I guess this would be a 2, right? 2. What happens here is that we know that 2 to the power of cube is just 8. So this cancels out. Minus 24 equals to 0. Breaking the middle term. What do we get after we break the middle term? 24 and 12 to the 24, right? So t square plus 12t minus 2t, rather it's the, wait, 12 to the 24, 6 into 2, 4, what do we get? Okay, 12 to the 24, 24 divided by 2 will not be there. Sorry, my bad. 6 for the 24, sorry, my bad. So plus 60 minus 40 minus 24 equals to 0. Taking this as brackets, taking t common here, this becomes t plus 6. Taking negative 4 common here, this becomes t plus 6. T minus 4, t plus 6 equals to 0, t equals to 4, t equals to negative 6. Just input x to the power of 1/3 equals to 4, x to the power of 1/3 equals to negative 6. Okay, so just cube on both sides. So this turns out to being x equals to 4 cube is 64 and cube on both sides. So here x turns out to being negative 216. Okay, these are your answers. All right, now question number 10 says, APGP question. Right, so the 7th term of an arithmetic progression is 77. Okay, so the generic equation of your terms are Tn equals to a plus n minus 1d. Since this is the 7th term, so this is basically a plus 7 minus 1 is 6d. This equals to 77. Okay. The sum of the first n terms of the progression is denoted by Sn. It is given that S11. So the sum formula, if I remember correctly, the sum formula is n upon 2. Let's just check it from here. Right, the sum formula is, where is it? Where is it? Yes. So n divided by 2, 2a plus n minus 1d. 2a plus n minus 1d. And since this is S11, so this turns out to being 11 upon 2, 2a plus 10d. Okay, what have they said? This equals to 880. So what we can do here is we're just going to make two terms, right? And then we're going to equate it together. This is the first equation. Let's simplify the other equation. So simplifying the other equation, what do we get? 880 multiplied by 2 divided by 11 gives us 160. So 2a plus 10d equals to 160. Everything, the entire equation divided by 2. The entire equation divided by 2 gives us a plus 5d equals to 80. So a equals to 80 minus 5d. Let's plug that in into the first equation. So we get what are we getting? 80 minus 5d plus 6d equals to 77. Solving this further, we get d equals to negative 3. And then using this equation, a equals to 80 minus 5 negative 3. A equals to 80 plus 15. A equals to 95. These are your answers. Okay, but what have they said? This is for A and D. That's not what they've asked for. They've asked for the 20th term of the progression. Using this formula over here, we get, let me change my color. Let me choose a different color. Let's choose this, right? Wait, let me just check one thing. Right. Okay. Right. Using this, what do we get? What do we get? T20 equals to the value of A is 95. 95 plus this is 20. So 19 times negative 3. Plugging this into the equation or the calculator, we get 38. And that is the final answer. Okay. Moving on to question number 10, part B. Find the smallest number of terms n such that the summation of n is less than 50. Okay, so nothing. The formula for summation of n is n upon 2, 2a plus n minus 1d. Using this, since we don't know the value of n, what we can assume here is that this is n upon 2. We do know that this is the repetitive of that. So 95 into 2. What is 95 into 2? We get 190. 90, basically the value of A is 95, right? And we don't know the value of n over here. So this is just n minus 1 into negative 3. This is less than 50. Okay. So what are we getting? Right. Okay, so let's try to finish this entire paper inside 10 minutes. Okay. Yes, that is going to be our, what is that? That is going to be our aim over here. Because time is less. Why is time less? Nobody knows. So this then turns out to being 190n, right? Plus n into negative 3n plus 3 less than basically this 2 shifts over here. This turns out to be 100. Okay, so 190n plus, or rather negative 3n square plus 3n less than 100. Shift everything to the right hand side. So this turns out to being 0 is greater than 3n square plus 193n minus 100. Or is it the other way around? Yeah, it's the other way around. My bad. Sign changes. Negative 190n, positive 100. Okay. Let's solve this equation, right? Let's just plug it into the calculator using shift n, or we can use the quadratic equation as well. Negative 190 plus minus b square, right? So 190 square minus 4 into 3 into 100 upon 2 into 3. Solving this in the calculator, the values of n that we are getting so we are getting n equals to 63.8 or n equals to 0.52. So n is greater than 63.8 or n is less than 0.52. So therefore n equals to 64 because n is a discrete value. Okay, question number 11 says the diagram shows the curve with equation this and a straight line. The straight line passes through stationary points. Is show that the equation of the straight line is this. Uh, okay. As you can see, it passes through the stationary point. So just we need to find out the dy by dx. The dy by dx is going to be negative 3x squared plus 18x minus 15, right? And at this point, it equals to 0. So solving this equation, right? Solving this equation, we get x equals to negative 18 plus minus 18 the whole thing square minus 4 into negative 3 into negative 15 upon 2 into negative 3. So what do we get? We get 18 square minus 4 into 3 into 15. So 614, and just let me just find out the values. So the value of x that we are getting is either 1 or the value of x is 5. So presumably this is 1 and this is 5. Show that the equation of the straight line is this. Okay, so we can just find out the y coordinates, right? So let's just find that out. This turns out to being negative 1 cubed plus 9, 1 squared, negative 15, negative 3. The coordinate is coming out to being, what is the coordinate coming out to being? The coordinates coming out to being for 1 is negative 10. And if we do the same thing, y equals to, 5 cubed. Negative 5 cubed plus 9 into 5 square, negative 15 into 5, negative 3. The value that we are getting over here is 22. Okay, so 1 comma negative 10, 5 comma 22, right? We need nothing else. We need to plug it into the equation y minus y1 equals to m times x minus x1. So y minus, let's choose the other one, 22 equals to, for m we need to do 22 plus 10 upon 5 minus 1. Okay, and then we have x minus 5. So have they given enough space? Okay, they haven't given us enough space. Okay, solving this further, we get y minus 22 equals to 22 plus 10 upon 5 minus 1, which is an 8. 8x plus 40, right? So we get the equation y equals to 8x 40 minus 22, y minus 18. We have proved this. Part B says verify that the curve also meets the straight line when x equals to 3. Right? So let's verify that. We have the equation of the straight line, which is y equals to 8x minus 18. We have the equation of the curve, which is negative x cube plus 9x square negative 15x minus 3. Did all of that by memory. Okay, so once we plug in the values of x equals to 3, what are we getting? 8, 3 minus 18. How much time do we have left? Around 4 minutes. Okay. So this turns out to being y equals to 8 into 3, 24. 24 minus 18 is a 6. And once we input this, negative 3 cube is a 9 plus 9 into 3 square. 9 is negative 15 into 3 is 45 minus 3. Y turns out to being negative 9 plus 81 minus 45 minus 3. So wait, 3 cube is 27. My bad. Right? Let's just change this to 27, or rather, okay, so the value that we are getting here is again 6. Okay, so hence we have verified this. Okay, so moving on to part C. Part C says the shaded region is bounded by the curve and the straight line. Find the area of the shaded region. Okay, shaded region is bounded by the curve. So that means that x equals to 3. Our limits are 3 to 5. So all we need to do is just integrate both of them, right? Integration of from 3 to 5 of the equation that we have. Area is negative x cube plus 9x square negative 15x negative 3, and then minus the, basically it's the upper curve minus the lower curve, right? So the upper curve over here is just the curve, and the lower curve is the straight line. So this turns out to being, and also we have to integrate this as well. So this turns out to being 8x minus 18. So we have to find out the area of the integration of, this turns out to being negative x cubed from 3 to 5. 9x square is just 9x square. And this turns out to being negative 23. 15 plus 8 is 23. And negative 3 plus minus 18 is negative 20. Wait, negative 3 plus 18. So positive 15. Okay, so integrate. We have to integrate this. So this turns out to being negative x to the power of 4 upon 4 plus 9 upon 3. So that becomes 3x cubed minus 23x squared upon 2 plus 15x, right? 5 to 3. So, let's input 5. What are we getting? Negative 625, I guess. 5 into 3, 5 cube is 125. 125 into 5 is 625. Plus 3 into 5 cube, 3 into 125, 3 into 125 gives us 375, right? Then we have over here 23 into 25. So negative 575 over 2 plus 15 into 5 is 75, right? This minus, once we input everything in 3, so that turns out to being a negative 81 over 4, right? 3 cubed is 27. 27 into 3 is 84. Then we have 3 into 27, which turns out to being 81, minus 23 into 9, which is 207 upon 2, plus 45. Plugging this in into the equation, right? We are getting 25 upon 4 minus 9 upon 4, which equals to 4.